Right, so on to question 2 in this mixed past paper questions of exponentials and hyperbolas. This question says, in the sketch below, not drawn to scale, is an exponential, which they've said is a to the power of x plus q. It passes through the point 214, and it has an asymptote at negative 2. It passes through the x-axis at b and the y-axis at a. Right, let's look at our first question. Determine the values of a and q. Now that should be fairly easy for us right now, so give that a try. Can I just be careful? This question says determine the values of a and q. So you actually have to explicitly tell me what those values are. So I can see that my horizontal asymptote is negative 2, so q is negative 2. And so all I actually need to do is find a. So this is a to the power of x. So a actually represents the base here, which we would normally call b, but there's no rules on what letter you use, which means I only have one unknown. So I'm going to substitute in 214. So that's a squared. I'm going to add 2 to both sides, and I get a squared is 16. Now, technically, this is an equation which has two unknowns. Two answers. Technically, you could square root 16 and get positive or negative 4. However, we only choose positive 4 because your base cannot be negative. So you don't actually have to write that. That's just a note for me. Technically, a squared equals 16 has two answers. But we don't bother finding the second one because it's not applicable. Now the question didn't say find the equation, so I don't actually have to give the equation. The question said find the values of a and q, and that's what I've done. Next question says determine the coordinates of a and b. Just be careful here. It says coordinates, which means once you've found your x and y intercepts, we must give them as coordinates. Okay, so y equals 4 to the power of x minus 2 is the equation. So if I let x equal to 0, I should be able to find my y-intercept. So y would be equal to 4 to the power of 0 minus 2, which is actually 1 minus 2, which is negative 1. So therefore my y-intercept, which is a, is the point 0 minus 1. If I go and find b, I'm going to say let y equal to 0. So 0 would be 4 to the power of x minus 2. So 2 would be equal to 4 to the power of x. Now this is quite a difficult one to do because that's an exponential equation. I need the same base on both sides. Now the one side has a base of 2. Now you can't get any smaller than 2, which means I need to rewrite the other side as a base of 2. So 4 is 2 squared. So then when I raise a power to another power, I multiply, and now I have the same base on both sides. So I'm used to having to make the 2 into the correct base, but in this case the base of 4 could be rewritten as 2 squared. So now I can equate my exponents. So 1 is equal to 2x, and I get x is equal to a half. So therefore that means that the coordinates of b are a half and 0. Which, if I look at the picture, it's never drawn to scale, but I did expect a positive value for b, and I did expect a negative y-intercept, and so that does look plausible. Okay, state the domain and range of f. Fairly common questions. We should know that the domain for all exponentials is x can be anything. There's no x value that x isn't allowed to be. Only in a hyperbola does it have a restriction. Now your range is your allowed values for y. So what can y be? Now unlike a hyperbola where y can be anything, y can't be anything here. It goes down to a minimum of negative 2 in this question. It doesn't actually reach negative 2 because it's always above negative 2. It doesn't actually reach that asymptote. So y must be greater than negative 2. Then it says, sketch the graph of y is equal to a to the negative x plus q. So just be careful, the graph that they gave you was y is equal to a to the x plus q. Now they're asking you to draw y is equal to a to the negative x. So when you change the sign of x, what transformation is that? That is a reflection over the y-axis. Don't forget that when you change the sign of x, you're reflecting over the y-axis. So my point at A would stay in exactly the same place. B would reflect over the y-axis. So that was at positive a half, so now it'll be a negative a half. And my asymptote would be exactly the same. So actually my graph would go through -2 through A and tend towards my asymptote. So it should look like a reflection over the y-axis. If I plotted another point, 214 would be at -214. Remember, you've simply changed the sign of x. And now it says, determine from your graph the value of x for which the original graph equals the new graph. So it does say determine from your graph because I can basically read it off. I can see that these graphs are equal to each other at A, and that is when x is equal to 0. So that's our first past paper question on the exponential. Well done.